All right, let's take a look at some examples of bases. First type of base we have are metal hydroxides. And the name kind of just tells you exactly what it is. So remember hydroxide, it was one of our polyatomic ions that you memorized, and it's an OH with the oxygen having 3 lone pairs and a negative charge. And so what happens with this hydroxide, right? It's got these 3 lone pairs, this negative charge. Whenever it encounters an H plus, it takes one of its lone pairs and picks up that H plus and then becomes water, right? So the electrons in this OH bond came from the lone pair of the water. So metal hydroxides, it's a metal and then hydroxide, duh, right? So most common one are sodium hydroxide, sodium's a metal, potassium hydroxide, potassium's a metal, and then you can have like group 2 elements as well. So for example, something like barium hydroxide, remember that barium has a +2 charge, hydroxide has a -1 charge, so we need 2 hydroxides for each barium. Those are the most common bases that you'll encounter in general chemistry. Another common type of base is a neutral nitrogen. So nitrogens tend to act as bases. So what it means when it says it's neutral is that we have a nitrogen with 3 bonds and 1 lone pair. So the most common example of this is ammonia, Nh3. But you have to be careful when you draw the Lewis structure for NH3, what you'll notice is that it has a lone pair. And so similar to hydroxide, it can take this lone pair and it can create a bond, right? So the electrons in that lone pair are creating a bond. And now we have this newly formed NH bond, and then that positive charge now belongs to the molecule. There's a lot of common nitrogen bases in compounds that in plants that we can eat and whatnot. So those are called alkaloids. An example of this is caffeine, right? If caffeine is a weak base, we can drink it, right? It acts as a stimulant for us. And then there's all kinds of other alkaloids that have different types of physiological effects. The final example of a base is sodium bicarbonate. This one gets kind of its own little topic. This is just baking soda. And so sodium, right, that's Na, and that's an ionic compound. So that's an Na plus, and then the counter ion bicarbonate is HCO3 minus, right? So you'll see it written out as NaHCO3, but think about it as an ionic compound. And the basic part of this molecule is the HCO3. And again, that acts the same, similar as hydroxide and the nitrogen. A lone pair goes and picks up an H plus.